Welcome back to our channel, dear students. Today, we are introducing the chapter Computer Organization and Architecture. And as the tradition specifies in our community Byte by Byte, the first video is always to list the different lessons we are going to have under this chapter. Remember that this is another vital chapter when it comes to Advanced Level Computer Science 795. So I recommend you to like, subscribe, and share in order to stay tuned to these videos. Okay, first of all, we are going to have introduction to computer organization and the stored program concept. That is, we are going to define computer organization. We shall move forward to define computer architecture, and we shall enter inside what we call the stored program concept, which is a very important concept when it comes to some specific type of computer architectures. From there, we move to the von Neumann architecture. We are going to look at the description of the von Neumann architecture. We are going to see the diagram of von Neumann architecture, the block diagram of the von Neumann architecture. We shall move forward to see the different problem faced by some computers having this architecture. From there, we are going to move to a different type of architecture known as the Harvard architecture, and we shall see the problems it solves in the von Neumann architecture, and we shall also see the differences between both. As well, the diagram and the block diagram for this architecture will be given. From there, we will move to parallel computer architecture, that is the different architecture precise according to the Flint taxonomy, where we shall see that there are four of them, and for each we are going to see how they are being used, how information and instructions are being managed. From there, we move to parallelism in computers. We are going to see how computers, the different techniques they put in place to perform parallel computing. From there, we shall see processors according to instruction set architecture, also known as the RISC and the CISC machines. From there, we are going to look at the processing unit and its component. And inside here, we are going to briefly define and explain the role of the different components present in the processing unit. After that, we shall go to the instruction cycle to see the different stages and um, the different stages and the different things that occurs when an instruction is being fetched till when it is executed. After that, we shall look at the factors affecting the performance of a processor. After looking at these factors, we shall move to the primary storage, where we are going to look at those different storages that are easily accessible by the CPU. And for each, we are going to briefly give the types in case there are. And we are also going to give the differences that we have between these different primary storage. From there, we move to secondary storage, where some calculations will be needed. There are different areas where we have calculations inside secondary storage. And inside the secondary storage, we are also going to look at these different factors that makes a secondary storage particular for a particular medium. Yes. From there, we are going to look at the input-output interface. So we are going to be talking about pulling and interrupt. We're also going to look at input-output controller and its function. From there, we move to the processor instruction set and its different architecture, where we are going to look at opcode, the different addressing modes, how they are being used, and yet there are calculations which are made as well. And it will be very important for us to understand. Equally, we are going to see how to be writing high-level code using assembly languages, using some mnemonic codes. And after that, as always, we are going to solve and answer past questions, be it CGCE or regional mock question. Thank you and see you in the next video where we are going to introduce the chapter computer organization. Thanks for watching. Do not forget to like, subscribe, and share the video for our community to grow. See you in lesson 1.